Right, so so let's take a look at the first problem. Okay, the smaller of the two consecutive integers is added to the numerator, and the larger integer is added to the denominator of the fraction. And what must the integers be if the resulting fraction is equal to 4/5? So after you add two consecutive numbers to the numerator and denominator, and after simplifying, you get 4/5. So the question is, what are the consecutive integers? Okay. Well, so for this type of problems, you need to name the variable, set up equations, then you solve the equations. So very first, don't guess and try. Okay, you should set up equations to solve the problem. Okay, so how do you name the variables? Now you have two variables right now, right? The two consecutive numbers, but actually they're related. They're called consecutive. Essentially, it's only one variable here, right? So you can name the, what do you want to find out? You want to find out the integers, right? All right, let's work on this. Step one. Right, two consecutive integers are usually denoted by n and n plus 1. Okay, so you add it to the numerator and the denominator. So 5 is plus n, and 7 is plus n plus 1. Okay, after you simplify, this should be equal to the value of a 4/5. Okay, then you get the equation, right? How do you solve this equation? Well, first of all, simplify a little bit, right? So 5 plus n, here's 8 plus n equals 4/5. It's harder to guess what is the value of n. So it's better to simplify this equation. You do the cross product. 5 plus n equals 4, right? 8 plus n. When you multiply this out, it will be 5 plus 5n equals 24 plus 4n, right? Or 32 there. 32. 4 times 8. So then n is going to be 32 minus 25, right? And that should be equal to 7. So then got two numbers, 7 and 8. That's all we have to get. So Angel, you get x equals -2. Now we're talking about integers, right? Of course, those integers could be negative. Right? Your answer should be two numbers, not just only one. Right. You can name the variables x. So here's n plus 1. Okay, right? Step 1. This is a word problem because it's on the numbers. Okay. Sometimes you have to use the properties. Those are numbers are being integer. Okay, because usually if you have a, sometimes you have an infinite many solutions, but if you're integers, then you only have one or two solutions. Okay. So take a look at the next problem. So the next problem, when the numerator of a common fraction in simplest form is decreased by 6, and the denominator is decreased by 10, the result of fraction is equivalent to the original equation after you modify. So what is the original number? Okay, as a common fraction. Maybe there's only one solution, maybe there are two solutions. And we do not assume this fraction is a positive number, maybe negative, right? Okay. Now this is a little bit more challenging than the previous problem. The reason is we have more than one unknown variables because the fraction is unknown, okay? The fraction is unknown, right? So after you decreased, the numerator decreased by 6, the denominator decreased by 10. And after you simplify, you get the same value as the original. Now, are you able to determine N and M here? That's the question. Okay. Yes or no? Okay. You cannot determine N and M separately. Maybe you still can determine the fraction. That's possible. Okay. Yeah, let me know if you figured out, okay, get the fraction. Okay, right? You write down the fraction in the form n over m. Then you read the question line by line, right? Read the question problem, yeah. And then you translate the sentence into an equation. So that the numerator is decreased by 6 and denominator decreased by 10. So that means minus 6 minus 10. Then after you simplify it, you should be able to get a same value. Now, Andrea, you get something, but why there is x and y there? And the answer will be just a number, a fraction. There's no other variables involved. Right? Then you double check your work once you get an answer, okay? Yeah, suppose the 5 over 3 is correct. For example, I just give you that, right? Does it satisfy the given information? Anyone else have an answer? All right, so let's solve this equation. So in general, if we have a over b equals c over d, right? If we combine them, this should be equal to a over b minus c over d, right? This should be 0. But then when you combine them, it will be ad minus bc and bd. So that means ad minus bc should be 0. So in other words, this cross product, ad minus bc should be 0. Okay? So using that equation, so we get this n minus 6 times m equals 10 minus m minus 10 times n. Okay. Okay, let's multiply this out. N times m minus 6 times m equals m times n minus 10 times n. So n, m canceled out. So what we get here is we get 6n m negative 10n. So from here, how can I get n over m? N over m is going to be negative 6 over negative 10. So negative 6 over negative 10 is 6 over 10. 6 over 10 is 3 over 5. Okay, 3 over 5, enjoy. So you did the opposite, upside down. Okay, because the original fraction is expressed as n over m. Right? At the very beginning, I didn't know whether we have only unique solution or not. It looks like, maybe we have more solutions. The reason is you have 2 unknowns, n over m, and only one equation, right? Usually you need 2 equations to get to solve for the 2 unknowns. That's true, but do we need 3 questions to find the value of n over m? No, just only one equation is enough. Okay. Why that happens? Because yes, you still cannot determine the value of n and m. However, the ratio is completely determined. Okay, the partial information, okay, is determined by this one single equation. Right? Okay, so now let's take a look at the next equation. Okay, before I solve this problem, let's talk about the nth power, right? If you have an equation ax equals a to the y, that equation can be simplified ax equals y. Of course, here a should be positive, a cannot be 0, okay? Cannot be 1. Otherwise, you don't have this item. Right. Right. That's one problem. Second problem is a to the x and to the y should be equal to a to the xy. That's a formula. For example, 2 square cube is going to be 2 to the 2 times is 2 to the 6. Okay, 2 times 3 is 6. All right, that's an example. And now after you know that, you can solve this problem. Okay, you have 3 equations, 2 unknowns. 2 unknowns will be m and n, right? Because this is a part of a pre-algebra. Okay. So my hint is you find the m first, then you find the n, step by step. Okay, if you have answers, let me know. Okay, I only see Andrew is giving the answers. So how about that hint? Okay. Anyone? Anyone has answer now? Okay, so let's use a formula, right? So let me finish the first one. 27. You want to compare both sides. You have to make sure both sides have the same base, right? So 27 is 3 what? 3 cube, right? Okay, 3 to 3, 3 cube then to the power m is going to be 3 to the 3m. So that implies 3m equals 1, so m equals 1/3. Okay. Now m equals 1/3, the second equation becomes is 1/3 to the power n equals 81. Now how can I compare both sides? Everything should be converted to 3. The right hand side is 3 to the negative n. The other side, 81 is 9 squared, 9 is 3 squared, so it's a 3 to the 4th power. Okay. 3 to the 4th power, so that means negative n should be equal to 4. Then n is going to be negative 4. So you find those two numbers, then you do the multiplication. Okay, so then nm equals negative 4 times 1/3 is negative 4/3. Okay. right? Got it? Yeah. Another property we used here is if you have this kind of thing, right? That's equal to a to the negative x. So those are the formulas we needed to know. Yeah, one before we solve the problem. It's called the exponents. It's part of a pre-algebra. Okay. All right. Okay, so let's move on to the next problem. I hope some of you can give me the answers, okay? So here's the question. The sum of the reciprocals of two consecutive integers is 7/12. Okay, and what is the sum of the two integers? If you use, if do the guess and try, maybe it's a quick way. There's two different ways to solve the problem. Okay. Write down the equation first. Okay. Write down the equation first. Okay, for the unknown. So there are essentially only one unknown here because there are two consecutive positive integers. Remember, right? One is denoted by n, other one is n plus 1. So it's just one variable. All right. So let's try and do it in two couple ways, okay? One is n plus, right? This is a reciprocal, the sum of reciprocals to consecutive integers. And this is supposed to be, add them together, right? So you add them together. It's going to be n plus 1. Here's n plus 1 plus n. It'll be 2n plus 1 and n plus 1. And that's supposed to be 7/12. Okay. Now, we can by guess and try. Okay. The reason is, suppose this is not simplified, just equal, right? You get a fraction for some n, and you cannot simplify, so you get so the numerator, the denominator is a product of two consecutive integers, and clearly, 12. Yeah, notice that 12 is 3 times 4, right? So you can think about, you can make guess, right? N may be equal to 3, and you double check. 2 times 3 equals 1. Yes. Then 2 times 3 plus 1 equals 7. Okay. Right? So that is what you can do. Right? So that is a quick way to do. The numerator is the sum of the two consecutive integers. Denominator is a product of two consecutive integers. If this cannot be simplified, then the product of the two consecutive integers is 12, then that must be 3 times 4. Okay? And then the sum of the 3 is 7. So you solve the problem immediately. Now, suppose you did not see this, what you can do? Okay? So the answer is 3, right? And suppose you cannot see this, then how do you do that? Well, you use the cross product. It's 2n plus 1 equals 7, n plus 1. Okay, this is a very complicated equation. Okay, if you multiply this out, 24n and 12, here's a 7n squared plus 7n. Finally, you have a 7n squared, right? You multiply this out, right? Then 24 minus 7, 7 minus 24 will be negative 17. And then you get a very complicated quadratic equation. Are you able to solve it? Yes, use a quadratic formula. You still can find it, okay? But this is just suppose, you did not realize, you cannot make a simple conjecture, right? So it's 2 times 7, and here should be positive 17 plus minus 7 squared plus, so it's plus 17 minus times 12, okay? So what's inside here you will get is 25, okay? Then you get two numbers. When you choose one number, when you choose a positive, okay, then you get 3. When you choose a negative, you get 4 over 7, negative 4 over 7. So only this n equals 3 is a positive. But this is, I just say, this will be complicated if you just want to solve this equation directly without the guess and try. Okay, but use a guess and try, you're lucky, can quickly figure the answer. All right, so take a look at the next problem. Okay, this is a trick. Yeah, find all the pairs of integers, and the first one is larger than the second one. So the product is 34. Yeah, do you understand this problem? Okay, so the first number should be larger than the second number, and the product is 34. Right? So 34 should be written as product of two integers. So that the second one is first one is larger, right? So 31. The first possible product is 34, right? 34 is 34 times 1. Then the second, because this is an even number, it's 17 times 2. I think that's it, because 17 is you only have, 17 is a prime number. So there's no other choices. So you have two solutions. Okay, 34 and 1, and 17 and 2. That's it. Okay. So remember that some integers is a prime number, then you cannot affect it. Okay. Keep this in mind, then you may be able to solve this problem. So let's take a look at the next one. Let n be two natural number. What does it mean, natural number? Natural number just 1, 2, 3, 4, 5, 6. Okay. If the product is a sum and their difference is 60, find the n. All right. So you have two unknowns, two numbers, only one equation. This is just only one equation. The product of their sum and their difference is going to be 60. Okay? You have to find the n and n. Only one equation, but you have two variables. So in general, you are not able to determine these two numbers. However, we assume that n and m are integers. Okay, this is a very strong condition. So you might able to completely determine those numbers. Or maybe you get a couple more solutions. Okay. Michael, thank you, Michael. No, that's for the previous problem. Yeah. Do you have any answers to the second problem? I think we're going to have a couple solutions to the second problem, to this problem number 6. So very important things, we have to use the condition, natural number. That means integers, positive integers, okay? So n times plus n minus m, the product is 60. So 60, right? How do you do 60? The first, this is large number, this is small number. So 60 is 60 times 1. It's also divided by 2, 30 times 2, right? Right? Then, what else? It's also, you increase, right? You can divide by, you can 3, right? So 3 is 20 times 3, right? And how about 4? I think here's 4, right? That's 15 times 4. Right? You have these numbers. And then you can continue. Right. So that it's harder to list all. Now, what you have to do is let's just factor. I'm going to just factor this, right? So 3 times 5 times 2 squared. Okay. All right. Now here's the important issue. So n plus m equals p, right? N minus m equals q. In order to make sure NM has a solution, I think a PQ must be both are even, must be both are odd. Because when add them together, the sum of P plus Q must be even. You know why? Because that's a 2N equals P plus Q. So either both are even or both are odd. Right? So that means either PQ are even or P and Q are odd, right? Now, how can make that happen? I think I can make them both are even. Then 2 should be distributed, right? So what is a possible product, right? There must be, can second happen? Both must be odd. I think it's impossible. Okay, if PQ both are odd, then all the factors must be odd. This is impossible. Okay, this is a product. P times Q should be 60, right? P times Q is 60. So if a PQ are odd, then the product is going to be odd. So now it's even. So PQ must be both are even, then this 2 should be separate. Okay. So what are the possible solutions? Right. Okay, what are the possible solutions? So 3 times 5, right? And I have 2 and a 2. So first of all, 3 times 5 times 30 times 2, both are even. Okay, and then And then you separate them, right? 3 and 5, right? So that'll be 6 times 10. I think that's all. Yeah, that's all, right? So then you have n plus m equals 30, n minus m equals 2. Another one is n plus m equals 10, n minus m equals 6. Right? Then you find both of them. Here, if here's 2n equals 32, when add them together, right? Add them together, you get 2n. 32n equals 16. Then m equals 30 minus 16, which is 14. So 16, 14. Okay. And another one is here as a add them together is going to be 16. So n equals 8. So m equals 10 minus 8. It's 2. 8 and the 2. So we have 2 sets of solutions. Okay. Yeah. 16 and 14 are one set of solution, am I correct? 8 and 2 is also another set. Yeah. Because 6 times 10 is 60. Then, so this is another possibility. Okay. So when, even we only have one equation, but if you n, m are integers, you might have you can determine the values n and m. Okay. Similar here. Okay, let's look at this equation. Read this question carefully. 2 positive integers, n and m are in positive integers. Satisfy this equation. What is the sum of n and m? So can you find n and m? One equation, but you have to use some properties like n and m both are integers. But actually, this problem is easier than the previous one. Previous one, 60 can be written as a product of seven numbers, right? Right? Anyone has answers? Okay. Anyone has answers? Michael, can you finish it? Can you do it? Lu Xiao. Any ideas? Okay, here's my hint. 17 is what? Can you express as a product two numbers? The only possibility is express it as 1 times 7, right? Okay, right? Still don't get it. So 17. So 17 is a prime number. The only possible way you can express 17 is 17 times 1. That's it. Right? That's my hint. That's the only way you can. And both n minus m are integers. So the only possible way to express them is n equals 17, this equal to. Okay? So this implies m equals n minus 1. So 17 minus 1, that's a 16. Right? So you get two solutions, 16. The sum of them will be, of course, on the test they wanted to get one number. So that's why it's 33. Okay? They don't want to enter two numbers, then which one is first, you know, it's confusing. It's not easy to grade it by the computer. Okay. Okay, the sum of three consecutive odd numbers is 45. What is the greatest of these numbers? Please work on this. Okay, how many unknowns here? Only one actually, because those three numbers consecutive numbers. If you know one of them, you can know the rest of them. So essentially, you only have one number, unknown. Consecutive odd number means they are odd next to each other, right? 5, 5, 7, 9. Those are three consecutive odd numbers. Okay, can you get it? Three consecutive numbers, right? How do you express it? Oh, you got it, MJ. Great. Okay, this is the number you got is in the middle. Okay, so let's see. The number in the middle is n. Three consecutive integers, right? Right, three consecutive integers. The other number is n plus 2, right? And then this is the other number, we assume that. Okay, maybe there's no solution. Okay, right? So three consecutive numbers, add them together is going to be just 3n, which is 45. Yeah. N equals 45 divided by 3 equals 15. So the n plus 3 is going to be 17. Right. So this is the greatest of these numbers, these integers. Enjoy, right? Did you see that? Okay, good. Yeah. Express if you are given three consecutive other numbers or even integers, expresses the middle one by x or by n, then other two should be either plus minus 2 or plus minus 1, depends whether there is a restriction on that, you know, additional condition on that. Okay. All right, so now let's take a look at the next one. All right. The sum of us three integers, okay, we don't know the relationship yet, okay, is 484. The two smaller ones are consecutive integers. Two larger ones are consecutive other integers. That's still okay, right? Find the product of the smallest one and the largest. Basically, you want to determine those three numbers. Okay, how can you do that? So you write down the one in the middle, okay, call it n. The two smaller ones are consecutive, so it's n minus 1, the other one, right? and the two larger ones consecutive other integers. So that means n plus 2, and this must be odd. Okay? So add them together. Maybe there's no solution here because when you add them together, you find the n. But the n is not odd, then there's no solution. Okay? So yeah, please work on this. Andrew says no solution. Yes, there's a solution, no solution. You did it too fast the computation. Double check your work. Okay. So Michael, we have two Michaels. Michael Ping, can you do the problem? Okay. All right. So let's look at this, right? So add them together this time. Now this time you will get 3n, right, plus 1, which is 484, and then you're trying to find the n, 483, right? Okay. Then you find that, then you solve for n, divided by 3, and this must be divisible, otherwise there's no solution. Indeed, then there's no solution. Okay. So the answer here is going to be 15. So n is indeed the odd number. Therefore, then you have a 14, 15, and 17, right? Then you find the you look at the product, okay? Then you look at the product. Okay. So the product is going to be, oh, Michael gave me big number, okay? Right? So you the smallest and largest two numbers product, right? 14 times 17 is 238. 238, huh? Nobody gave me the same answer. 238, right? Okay. It's not a 482. Let me double check, okay? 483 divided by 3. Hold on. Okay, hold on. 483. Yeah, I missed. Did it too far. Okay. So this is a divide by 3, sorry. Divide by 3 is going to be 161, okay? Then it's 100, this is other number, 160, 161, 163. That's it. Yeah. Then you multiply this. Sorry. So that should be 2608. Great. Yeah, I don't know what happened. Okay, so it's 161. Okay, so 15. All right, so yeah, just be careful when you do the division. I use a kicker, so I just aim to the wrong number. Okay, so here's another problem. Okay, yeah, here's another problem. So you have one A, B, C, D, E are 5 consecutive integers. If you know the sum of B, C, D, 3 middle one is 39. What is the value of A, B, the sum of these 5 numbers? So the previous one is wrong. Let me double check it. You work on this, okay? You have 5 consecutive integers. No, we're not asking to find the sum of this three numbers. We just find the greatest of these 3 digits. So different questions. All right, so let's take a look at this number, okay? Okay. You see, 5 digit consecutive integers. So you can express in the form n plus 1, n plus 2, n minus 1, n minus 2. So those are the 3 numbers, B, C, D. Okay. So if the sum of these integers when add them together is 3n equals 39. So what do you get? N is going to be right 13. Right? N is going to be 13. So no, N is 11. Yeah. 11 times that's 39, right? 13. So once you get 13, right? Then let's double check. Okay, let's check. B, C, D is in the middle. Yeah, B, C, D is in the middle, right? So because you have other number of 5 consecutive integers, so the one in the middle you add them, right? One in the middle you write as the n. Okay. Then the sum of the 5, just 5n. So A plus B plus C plus D plus E is just 5n. So all I have to do is just 13 times 5, 65. Right? Andrew says 165. Okay, this is the sum of this. That's 5 digits. Got it? 65. All right. Yeah, sometimes if you do computation by mind, it's easy to make mistakes. So you should work on a piece of paper, use a calculator, then you will get the right answer. So this is the example I'll show you again, how to express consecutive integers. Okay, if you have 5 consecutive integers, then you express the one in the middle by n, then plus minus 1 plus minus 2. So you get total 5. Okay. All right, now So number 12 can be written as the sum of 8 consecutive integers. What is the product of these integers? Wow, you have 8 consecutive integers. And the sum is 12. Eight is an odd number, so that's why I don't know what is the best way to express, because other consecutive integers. You cannot say here's the middle one, then plus minus 1 plus minus 2, right? And plus minus 3. So you probably have to write the beginning with the first one, right? You know, first one is n plus 1, n plus 2, n plus 3, n plus 4, n plus 5, n plus 6, n plus 7. So in total you get 8, right? If you don't want to express them in this way, then you have to figure out the 2 middle one, right? Okay, now you can try another one. Okay, probably it's still better, even odd number, even you have even consecutive integers. So 2, 1 in the middle is n plus 1, n plus 1, right? Then n minus 1, n plus 2, right? So we have 4 here. N minus 2, n plus 3, 1, 2, 3, 6. So n minus 3, n plus 4. Total, you have how many of them? You have 8. 4 and 4. The sum is going to be, first of all, how many n here? 8 n here. Then n minus 1 plus 1 can, 1 cancel out, 2 cancel out, 3 cancel out, but 4 is not canceled, right? So that's going to be 12. Then 8n is going to be what? Is going to be 8. So n is going to be 1. So the 1 in the middle is a 1. So you get the 1, you get 0, negative 1, negative 3. Here's 2, 3, and 4. So clearly the product is going to be 0. Because in this sequence, there is a 0. So the product is going to be 0. I think it's better to express consecutive integers in this form, okay? So there are lots of cancellation here. Okay, let's take a look at the next problem. Okay, what positive integers are 56 less than its square? Okay. So what does that mean? That means a positive integer is n, right? N is going to be 56 less than its square. So you get the equation n squared minus n minus 56. Now it's better to factor it, okay? If you're able to factor it, then it's minus 8, because 56 is going to be 7 times 8, right? So one of them should be negative if it's negative 56. So maybe I can try 7 times negative 8. So the sum of them would be negative 1. The product is negative, right? So that's why it's n plus 7 equals 0. We are talking about positive integers. So n should be equal to 8. Okay, then you solve the problem. Right? Yeah, just write down the equation. Okay, now take a look at the next problem. What is the value for n? Find the integer such that the sum of those n integers is 153. Okay. The only formula we needed to know is when add them together, this is n plus 1 divided by 2 equals 153. So n plus 1 equals 153 times 2. So left-hand side is the product of two consecutive integers. The right-hand side is not. So you should factor 153. 153 is divisible by at least by 3. Okay, so it's going to be right. 153 is divided by 3, so it's a 51 times 3 times 2. Hold on. Just a second. Okay. 153. Yes. Then 51 is 51 prime number. Okay, is 51 prime number. 51 is also divided by 3. Clear? Because 5 plus 1 is a 6. So it's divided by 3. When divided by 3, you get 17. Okay? Okay. So then you will say it's a 17 plus 8 times 18. So clearly n should be equal to 17. Right? That's how to get. You don't need to solve this quadratic equation because you see the product to consecutive integers is 17 times 18, so it must be 17. Right? So the only formula you need to know is this. 1 plus 2 plus 3 plus 4 all the way to n is n times n plus 1 divided by 2. Okay, finally, let's work on the last problem. This bigger number is a product of several consecutive positive odd numbers. What is the greatest of these numbers? So we have to factor this number step by step. Okay, so what is the best way to factor this number? Here's what do we do. First of all, you divide this by 5 because this is a number is divisible by 5 clearly, right? And this 295 divided by 5, you can use a calculator. It's a 459,459 times 5. Now 229729, but 4. Okay, this 2 as a same number. Okay, so maybe you can shorten this. Okay, this is going to be 1001 405 times 100. I think it's 101 times 5 because 1001, right? And if you multiply 5, right? And then add them together, you get this 6-digit number. So the next step is to continue fact those two bigger numbers. But the 459 is divisible by, okay, 459 is divisible by 9. Why? Because the sum of the digits is going to be sum of digits is 9. But the 51 already know that, right? 51 is divisible by 3. So it's a 17 times 3 times 9. We're almost done here. Now 101 is very challenging. Okay? 101. Okay? This is a number we don't know. It's not divisible by 3. It's not divisible by 9. It's not divisible by 5. It's not, right? So next, the prime number you can try if you don't remember, right? The number, you can try is 11. Okay, prime number. Yeah, then when you divide by 11, then you get 91. But we already know 91 is not is divisible by it's not prime number, right? 91. Okay, so 91, as to my best knowledge, 91 is not divisible by 11. Okay, 91 is not divisible by 11, but 91 is divisible by, you can try negative number. So next prime number is 13. So it's 3 times 13. Okay, so once you get those, then you can easily list all of them. Okay, you have, you have a 17. Yeah, we're almost done. Okay, you have a, this is how do we factor this number, right? Now you begin with a, we begin with which number, right? Begin with okay, let's try. I think I should begin with a 7. Any factors here? 7? No, no 7. Let me check. 17th. Do we miss any number? Yeah, divide by 13. This is a 7. So yeah, 7 times 13, not 3 times 7. So we begin 7, and then have a 9, because these are other numbers, right? Then 11. You cross this one by one, then you list them, right? Then 9 and the 7, then 13, right? Then 3 times 5, 15, then 17. Oops, that's all we did. Okay. So this I just trying to show sometimes you need the help for this well-known theorems, how to check a number is divisible by 3 or 9 or 11. Then you also can try some prime numbers, small prime numbers, to see whether we can use them to divide the whole number, right? The remaining number, and then step by step we can factor the whole number. Okay, so those are the problems about the numbers, and next we're going to study different problems. Okay, so we are done with the problems on numbers. Okay, so we have 3 more lessons in April.